So now we are gonna start analyzing applications of these kind of problems. Now we have this student that apparently is super strong and she doesn't know it, but she's like a She-Hulk. And well, whenever we start analyzing motion in 2 dimension and projectile motion, we should first start making a drawing. The drawing maybe is the most important part of it, so we can understand fully the problem. So we make our axis, and well, let me change the color. We're gonna draw the initial velocity here. It has a magnitude of 24.5, and the angle is 36.9 degrees. Okay, so first thing we need to know is that velocity has two components. Remember, don't forget that. It has the x component and it has the y component. And from that we should start our analysis. Okay, don't forget that Vx is equal to the initial velocity cosine of theta, and the initial velocity in y is v0 sine of theta. Okay, these things should also stay deep into your heart. Okay, now from there we can start working with other stuff. Now we're asked for the total time in which the cap is in the air. Okay, so actually this little cap is gonna make this path and eventually it's gonna land. Okay, so we need to find the total time it's in the air. How do we do that? Well, easily. The thing is that the motion in y is given by gravity and it will make it fall. So that's the thing that will determine the time it is in the air. So we use our powerful equation that you should know by now. That's this plus v0 in y times t minus a half of the gravity times squared. Okay, we can start substituting these things. So if we're told that someone catches it at the same height, okay, so we can assume that it's gonna be catched at the same spot. So 0 is the final place and 0 is the initial place. Okay, so initial velocity in y is gonna be 24.5 sine of 36.9. Let me use parentheses so that we don't get screwed. Times t minus a half of 9.81 times t squared. Okay, so from here we can solve for t. So here I'm gonna get 24.5 sine of 36.9, all of this multiplied by t, it's equal to a half of 9.81 t squared. Okay, as there are t's in both sides, I just can get rid of this guy and this guy over here and solve for t. I'm gonna be left with 24.5 sine of 36.9 over a half of 9.81, and that's gonna be t. And if you solve that in your calculator, you're gonna get 2.99 seconds. Okay, so that's our first answer. Finally, we need to find the total distance traveled, and for that, we should let me change colors into this nice, I don't know, a green. We'll do it. We need to find the total displacement in the x-axis, and for that we just know that x is equal to x0 plus v0 in x times t. So we can assume this thing is going to be 0, and the initial velocity in x It's gonna be 24.5 cosine of 36.9 times this time we just found out, times, let me use parentheses, times 2.99, and that is gonna give us something very, very close to 58.8. That's gonna change a little bit depending on how many decimals you used, but okay. So this is the result. Don't forget that the velocity in x is gonna be constant. Yep. So there's no acceleration here, and in the y-axis we actually have acceleration all the time.